Hi, and welcome to this episode of What's New in AL. My name is Esben Johs Christoffersen, and in this episode I will discuss the enhancements that we have made to interfaces in this release. It is more than 4 years since we first released interfaces in AL, and although it was integrated with enums for extensibility from the beginning, we have discovered some limitations with that over time. And with a couple of new features, we are going to address this in this release. To show how those new features can actually help you build better extensibility, I have created a small sample app that I'm going to use in this episode. It is a shipping cost calculator. It allows you to enter a distance and a weight, and it will then calculate shipping costs. And it is built as a provider model, so it allows other third parties to create their own extensions that plugs into the model from code in their own app. And those will be discovered lately and are then available to the calculator. It is a fairly simple UI. On the top, there's a place to input data, distance, weight, and at the bottom, the different costs are shown in the list. As I mentioned, it is a typical provider model. So the calculator app defines an interface for providers to calculate cost based on input. And there's an enum that allows the shipping provider vendors to add themselves into this calculator. Now, let's move from the slides into the actual code. The sample app consists of 3 small apps. There's the shipping cost calculator, which is the orchestrator, the one that defines the interface and actually does the calculation and contains the UI. And then there are 2 other apps. There's standard shipping and express shipping. They are meant to illustrate how different vendors can add their own calculations into the calculator. Let's start with the interface. And I will just get rid of this over there. The interface is simple. It's called iShippingProvider. There's a method that just returns the provider name. It can be my own shipping or whatever. It's just a string. And then there's the method, which is actually the important part, the calculate shipping cost. It calculates the cost given a distance and a weight and returns true if it actually calculates something. And if it returns true, it will also have populated the cost record. Next up is the enum. It's probably even simpler. It's just a definition of an extensible enum called shipping vendor, and it implements the shipping provider. And as you probably know, that means that all extensions that actually adds a value must also define a code unit that implements the shipping provider. This is how we built extensibility into enums 4 years ago. Then there's the shipping cost orchestrator. It is a code unit. It essentially loops over all the enum values defined by extensions to the shipping vendor. This is what is going on here down there in the for each statement, for each shipping provider in the shipping vendor. It extracts the provider, which is the interface. And for all those interfaces, it calls calculate shipping cost and adds that to the result record set. And this code unit is called from the UI. It's the page on every changed value in the input fields. It will call this to calculate costs. Implementing a shipping provider is now easy for a vendor. All they need to do is to create an enum extension with their own name and a value, and give it a caption. In this case, it's Grand Pass Shipping, and it defines that a shipping provider is implemented by the standard shipping provider code unit. Standard shipping provider code unit, in this case, is also fairly simple. It has to provide the methods defined by the interface. In this case, it's the get provider name, in this case, Grand Pass Shipping. And then it calculates a shipping cost based on distance and weight. And in this case, distance is multiplied by 0.5 and weight is multiplied by 0.1. And the delivery time is 5 days. And It also has a description which shows up in the UI, which is reliable and cheap shipping. Sounds good. The diagram here shows how this is the architecture behind this. There's the code unit, knows about the shipping vendor and the shipping provider interface. The three top-level boxes are what is contained into the calculator itself. It doesn't provide any providers itself. It relies on other third parties to deliver their own calculations. And in this case, I have added the standard shipping vendor and the standard shipping provider at the bottom, showing how an external party can actually add into the calculation. This is how we envisioned this a couple of years ago. But if we take a look at this, it's not without challenges, because nothing is static. This is software. At some point, someone wants to actually use dimensions as input, or maybe at some point in the future, we want to ship to, I don't know, other galaxies or something. And the current interface is not really providing any good ways of specifying that. So what we would like to do is add a new method to the interface, but that breaks all the existing provider apps, because otherwise they will all have to update their own code and go in and add this method, even though they may not want to ship to other galaxies or provide dimension calculations. Changing the method, adding another argument or so, that also breaks all the existing providers. Actually changing anything on the interface breaks existing providers. So another option would be we could create a new interface and a new enum. That's possible, but the existing interface could be big. We may even have used it all sorts of places in our own code base that we will now have to create a complete parallel code path to cater for. And this could lead to a lot of code duplication, and the next time we need to change something with regards to shipping, should we then create another parallel implementation? It doesn't really sound appealing in any way. All we want is just to extend the existing interface without changing or breaking everything. So what we have now introduced is a way to extend interfaces. This allows you to create a new interface that extends an existing interface. In this case, I have created the iExpress shipping provider. It allows vendors to add calculations for express shipping. Well, let's just say overnight shipping or something. And they can add a new method to the existing interface. This is one of the new features, extending interfaces. Syntax is, you have the normal interface declaration, and then you add extends and then a list of interfaces that this interface extends. It also means that all implementers of the new interface must implement all the methods from all the interfaces, both the interface itself and all the interface it extends and potential interfaces that those extends. So it will be a combined list of all the methods from all the extended interfaces. How would this look? As you can see here, this is the Express Shipping Provider. It implements the Express Shipping Provider interface, which also implicitly means that it implements the iShipping Provider. I haven't specified it on the implements section here, but it's implicit because iExpress Shipping Provider implements iShipping Provider. In this case, I have to implement all three methods. Get provider name. In this case, it's shipping ROS. The calculates shipping cost, the one that came from the original interface. And now the new method here, calculate express shipping costs. For the enum here, you can see I actually only specifies the iShipping Provider as being implemented as the Express Shipping Provider. And it still works because Express Shipping Provider implicitly implements the iShipping Provider. So you can see it here. Also, it implements the original interface. Now we come to the next feature, which is actually 2-in-1. Because it's not enough just to create a new interface. That would still be breaking. But the trick here is that we never changed the enum. The enum is still only providing the iShipping provider interface. And that means that all the extensions out there implementing that and adding a value to the enum with that interface will still work. But then is the trick, how can we actually access those that implements the new improved interface? And this is what we do down here. We have added a new way of checking whether an interface implements another interface. This is the first line. If provider is Express Shipping Provider, it's a Boolean expression that tests if the provider also implements iExpress Shipping Provider. And if it does that, then we can cast it using the as expression, which is also new. So we can say if provider as iExpress Shipping Provider, the result of that expression is now a iExpress Shipping Provider. And then we can call the calculate express shipping cost on that provider, because now we have changed it to be an iExpress Shipping Provider. And then we can add the results to the costs again. So if you look at the syntax here, first the is operator. That's the checking part. And in this case, the example takes an unknown interface, which is also something we added to the system application. We have added an unknown interface that you can use that gives a common ground for anyone who wants this kind of generic functionality. So I use this as an example here. So I can test whether the interface here, unknown passed to this method, is actually an iExtended Shipping Provider interface or supports it. The left side must be an instance, either variable or parameter, of type interface or variant. And yes, you can also use a variant here, and it will look inside the variant, check if there's a code unit, and check if that code unit actually implements the interface type specified on the right side. The as operator syntax is very much alike, but the result value is instead an interface of the type of the right side. And in case that the left side cannot be cast to the right side, you will get an error. And this is why you should, in most cases, check first whether the interface you want to cast to is actually implemented. And now it's demo time. So let's try to see how it looks. We have the shipping cost calculator. I can enter distance and weight. Let me just start by enter a distance, 100 kilometers, and already here I get some, even though there is no weight on it. Let's say it 5 kilos. And as you can see, I actually get 2 cost calculations from ShippingRS. That's the one that actually implements the new express cost. And I can get both an eco-friendly shipping by horses and super fast trains, planes, and automobiles. And for the old Grand Pass shipping, doesn't support the new express delivery, so it will only provide me with reliable and cheap shipping. The sample I have shown here is of course a very simplified version of reality. You have all extensibility requirements which are much more complex than what I have shown here. This is a boiled down version suitable for a video, but you will probably have to do a lot more work around this when you implement this yourself. But I think this is a very good addition to the existing interface feature that will make it a lot more useful. Thank you for watching, and hope you will use this to improve your own extensibility. Thank you.